Good afternoon. Welcome to today's webinar hosted by NOAA's National Integrated Drought Information System. My name is Elizabeth Waite. I'm a program coordinator with the National Integrated Drought Information System, or NIDIS. Today, I'm honored to have John Fleck as our speaker on the topic of coping with megadrought in the Colorado River Basin. As a former science journalist turned academic, John is focused on the problems of the Colorado River, which is an imperiled water resource on which 40 million people in the United States and Mexico depend. As a professor of practice in water policy and governance at the University of New Mexico's Department of Economics and director of the university's Water Resources Program, John co-teaches classes in contemporary water policy issues, modeling, and technical communication for water managers. He first wrote about water in the 1980s as a beat reporter covering the Metropolitan Water District of Southern California. He's the author of the books Water is for Fighting Over and Other Myths About Water in the West, which is an exploration of solutions to the Colorado River Basin's water problems. And he is a co-author of Science Be Damned, How Ignoring Inconvenient Science Drained the Colorado River. In this webinar, I'll share a brief overview about the National Integrated Drought Information System, and then John Fleck will present on coping with megadrought in the Colorado Basin. After his presentation, we'll open the webinar for your questions. Throughout the webinar, everyone is muted. So if you have a question for John, please write your question in the question box in the GoToMeeting control panel. At the close of the webinar, a survey will pop up, and we ask you to please take a moment to answer the 4 brief questions to provide us with feedback on the webinar. And finally, today's webinar is being recorded, and the webinar recording will be available on drought.gov, and the address of drought.gov is at the bottom of this slide. So very briefly about NIDIS. NIDIS was created by congressional law in 2006 and reauthorized in 2014 and again in 2019 with a mandate to help the nation prepare for, mitigate, and respond to the effects of drought by establishing a national drought early warning system. And NIDIS achieves that goal through the development of regional drought early warning systems. Those are shown on the map here. And in those regional drought early warning systems, networks of partners and stakeholders support communities to prepare for drought. NIDIS also supports research to improve drought predictions and forecasting, as well as drought monitoring, and also effective drought planning and preparedness. And all of our work is done in collaboration with a wide range of partners at all levels. I encourage everyone on this webinar, if you're interested, to explore the U.S. Drought portal at www.drought.gov. Where NIDIS hosts a wealth of drought resources, including data, information, tools, and research. In addition to the regional drought early warning systems and the U.S. Drought portal, NIDIS also works on several national scale initiatives, including drought and public health, drought and wildfire, drought impact reporting and analysis, drought indicators and triggers, and the National Coordinated Soil Moisture Monitoring Network. And finally, NIDIS offers webinars of relevance to the country. On this slide are several upcoming webinars that may be of interest. On June 3rd, we'll host a national webinar on drought decision-making tools that you can use. This webinar will introduce you to 2 tools available for drought monitoring across the continental US. Presented by Catherine Hegovich, she's a research scientist at the University of Idaho, as well as Rebecca Ward. She's the assistant state climatologist for North Carolina. And also Jeff Marty, the drought coordinator for Washington State, will join us and share with us how he uses one of those tools for drought monitoring in the state of Washington. And then NIDIS also hosts webinars in most of the regional drought early warning systems. You can see here some of the upcoming regional webinars, including preparing for the fire season in California and Nevada, and regular climate webinars for the Southeast, the ACF Basin, and the Pacific Northwest regions. In addition, there is a webinar series, a monthly webinar series in which NIDIS and partners provide weather outlooks for tribal nations and pueblos in New Mexico. To register for these and other NIDIS webinars, or if you're interested in learning more about NIDIS, please go to drought.gov or feel free to contact me. And then now I will turn the presentation over to you, John, with our thanks for sharing your expertise with us today.
Thanks much for having me. Can folks see my slides?
Yes.
Excellent.
Thank you very much.
And it's particularly great for me to have a chance to talk to folks through NIDIS. I had the opportunity close to 15 years ago, shortly after the initial authorizing legislation, to spend a few days with the NIDIS science team shortly after NIDIS was stood up, meeting in Santa Fe, where I learned a lot that has lingered to this day, helping me think about drought and what we mean by drought, and a network of connections, some of whom have become integral to the work that I do today as a university professor. NIDIS is a great institution. I want to talk today about drought and megadrought in the Colorado River Basin. And I would like to go over kind of four key themes. I want to talk about the year we're in today, the year we're in 2020, what's happening on the ground right now, what my friend and collaborator Eric Kuhn has dubbed a sneaky drought, and how that connects up with this longer term idea of a mega drought that Park Williams talked about in a previous NIDIS webinar, and Park and others have been writing about in the scientific literature. I want to talk about policy successes to date in the Colorado River Basin. We have done some remarkable things to increase our resilience and adaptive capacity and reduce our risk. And I want to conclude by discussing what I think are some of the challenges that we have ahead of us, because we've only begun to deal with the reality of the impact of climate change on this basin. And there's a lot of work that remains ahead of us. Let me start with a geographic overview. And I do this in part because I'm imagining that there's a lot of people in this audience who are not from the Colorado River Basin, but also we tend to live in our little piece, even when we're in the Colorado River Basin, we tend to live in our little piece of the basin. And it's important to think about this as a large-scale hydrologic system that really spans 2 nations, 9 states. There's 7 states in the United States, 2 states in Mexico. We sometimes forget that this is a river shared across an international border. We have 29 Indian tribes, and I think there are some really important issues for thinking about how we deal with the legal and ethical obligations we have to among Native American communities and sort of Anglo settler communities that have kind of plopped down on top of this land over the last 100 years. 5 million acres of irrigated farmland. Like, we're not Iowa, right? But there is a lot of food grown here, and I can pretty much guarantee that in the last month, every single one of you listening has eaten some food grown with water put on a farm that comes from the Colorado River. And then 40 million or so people in and around the Colorado River Basin who depend on it. I live over on the right-hand side of this map in Albuquerque, that black hatched area in New Mexico. We get our water, take it out of the Colorado River Basin through some tunnels, put it into our water system, and the glass of water sitting on my desk next to me has Colorado River water in it. So the same with Denver and the Front Range of Colorado, Salt Lake City, Las Vegas and Phoenix are in the Colorado River Basin, but essentially pump Colorado River water uphill to dry desert valleys, almost like they're in a different basin. And then Los Angeles and San Diego. So we have people all across the West depending on this really, really complicated interlocking system. So in this system, where we are 40 million strong and 5 million acres depending on the Colorado River, we have been, sort of creeping up on us for the last few months. What my friend and collaborator Eric Kuhn, co-author of my most recent book, dubbed a sneaky drought. Eric's got a talent for clever names for our weather conditions that have a way of sticking. So we're all now calling it the sneaky drought. Thanks, Eric, if you're listening. And how did this sneak up on us? It snuck up on us because there seemed like there was kind of a lot of snow. And so this is the standard Colorado Basin River Forecast Center. Huge thanks to NOAA and the CBRFC folks for amazing data and analysis that we all use to think about the river. The purple line is kind of the normal rise and fall of snowpack in the mountains of Colorado and Wyoming and Utah that feed the river. The blue line is, so the purple line is the median, the blue line is what this year looked like. And, you know, up through the end of March, looked like kind of a normal snow year. The green is last year. We were spoiled with a very wet year in 2019. And then this happened. And this is a bit of a busy graph, but it's the one that we look at in Colorado River Basin Management all the time to kind of see how things are going. The blue line tracks the forecast day by day by day. And you can see that, you know, in the middle of February, it was looking like close to a normal forecast. And then the bottom just kept dropping out of it and dropping out of it. And we have now, this is sort of an annual runoff from the sort of April to July key summer runoff season. We have a very dry year as a result of this, as a result of the sneaky drought. So how did this happen? How did a decent looking snowpack turn into a really lousy runoff year? We live in a drying landscape. And year-to-year weather makes it hard for the scientists who work on this to tease out the signal of the changing climate as a result of anthropogenic warming. We know it's happening year to year. We have a lot of interannual variability that sometimes masks it, but whatever combination of causes, and I'll talk a little bit more about the anthropogenic component of this in a minute, whatever the combination of causes, we had a really dry late summer and fall last year. So this is a map produced again by the wonderful folks at the Colorado Basin River Forecast Center, the CBRFC, modeled soil moisture heading into the winter snow season. And you can see, especially in the Rocky Mountains of Colorado, where a big fraction of our snowpack comes from, incredibly dry soil moisture. The reds and oranges and these ghastly purples are dry relative to the long-term average. And so in this critical snowmaking area, incredibly dry snow. Dry across a lot of the other parts of the basin, but this is where the bulk of the water comes from here in the mountains of Colorado. Super dry. What does that mean? Well, it means that as the snow finally begins to melt in the spring, a big chunk of it ends up not flowing down into the rivers, but just soaking in, wetting that very, very dry soil and shallow aquifers, shallow groundwater. And so a big chunk of the runoff just never has a chance to make it to the river. And then in March, but especially in April, it got super dry. It was warm as well, but especially dry. And so at the same time, the soil is soaking up what melt there is, no new snow or very little new snow is being added. So we are always vulnerable in terms of water supply in the Colorado River Basin to the trends in these late March and April snowpack. We were headed for a particularly droughty year in, I think it was 2015, and we had what, again, the clever namer of our droughts, Eric Kuhn, dubbed the Miracle May, when it suddenly got really wet in May and bailed us out. That did not happen this year. So the result is a really low runoff headed into the rivers just at the very beginning. That's this year's sneaky drought. Any one year can be dry or wet. We know there's a ton of natural variability, but what do we know about those big picture underlying trends? And folks who are regulars on the webinar series have already heard Park Williams talk about this stuff. So I don't want to go into a lot of details, but this is from a paper by earlier this year in Science by Park Williams and colleagues, looking at proxies, climate proxies for these summer fall season soil moistures, which are critical. And what they concluded is the first 2 decades by this as a measure, the driest perhaps since the 1500s, one of the driest on a very long time series. And this is the critical piece of what Park Williams in his work, and a lot of other people who have done this. This is not the lone paper talking about this. Anthropogenic warming, the rise in greenhouse gases and the attendant changes in the climate with warming, shifting of storm tracks and those patterns is responsible for perhaps half of the dryness. In other words, it would have been a drought anyway. It was made substantially worse by anthropogenic warming. And I think that is the challenge that we face as we deal with climate change going forward. So let's talk about what we do about this. What are the policy responses? How do we as communities respond to, I'm going to use the word drought here, but we're talking about something deep enough and long-term enough that there's a significant discussion in the scientific community about whether we just need a word that makes it a little clearer that this is not a temporary phenomenon. My friend Brad Udall, who I met at a NIDIS meeting, talks about the word aridification as a better way of thinking about this. It feels like a drought in terms of the things we need to do respond, but we don't need to be fooled by our use of that word to think that it's a temporary situation that will swing back into a pluvial to a wet time period. So that's the sort of scientific foundation that I want to lay for what I'm talking about. I work on policy. My faculty appointment is in water policy and governance. I work on taking the science, but the scientists like Park Williams and Brad Udall and the others develop, and thinking about how we incorporate it in our policy responses. So I want to talk about what the policy framework in the Colorado River is, and then how the system is responding to both short and long-term changes that we are seeing. And it is really important to remember that point that I made before. We have 2 nations, 9 states, 7 in one country, 2 in another, 29 tribes, farmland, cities, and we have this governance structure that puzzled me for the longest time when I first started trying to write about it and read about it and explain it. Kind of no one's in charge. We have this interlocking collaborative governance structure that depends on the collaboration and the working together of a whole bunch of different parties in each state and each water agency in each country and each group of water users. And it makes solving these problems difficult, but there also is a fascinating social science literature that suggests also it creates a great strength because we do a good job of incorporating the many different values. And I want to talk about some of those different communities and what those values are around the use of water as we think about how we cope with the fact that we have less of it. So let's talk about some history. We cannot disentangle the modern West from a series of decisions that were made over the century that has gone before to build really, really large water management infrastructure. We built Hoover Dam in the 1930s. At the time, the largest dam in the world, still one of the largest dams in the world, both in terms of the size of the structure and also in terms of the amount of water it stored. In the 1960s, we built Glen Canyon Dam, creating Lake Powell, enormous again. And so what we have ended up with those 2 big dams. So Lake Powell's kind of there on the Arizona, Utah border. Lake Mead and Hoover Dam is on the Arizona, Nevada border, just outside of Las Vegas. And we built a bunch of dams that on their own are quite large, but relatively smaller than those two. And in the process, we ended up building over the course of the 21st century enough storage to hold 5 times the Colorado River's annual flow. I mean, if you look at large scale water systems, this is a staggering amount of storage. This is a stunning amount of storage. And it's based on the idea that in wet years, you store up water so that you have it available in use for dry years. There's a great truism in water management that I've never been able to find the origins of or who said it first, but that canals move water in space and dams move water in time. We can capture water during the wet time and shift it over to the next year and use it during the dry times. Whole bunch of downsides to that, right? We have all this evaporation, but it's a very effective tool in an arid climate with a highly variable river flow like this to allow us to have cities like, the Albuquerque that I know and love. And really importantly, in terms of the megadrought of the 21st century, we began the 21st century, thankfully for the modern West, with these reservoirs nearly full. Now, as you can see from the pictures, they are not. That little sort of running picture on the right-hand side is blown up here in full on the left, so you can see it. This is taken in March, my last pre-pandemic trip to see the Colorado River. I'm super sad because I really wanted to get out to see the river and talk to its people this summer, and I'm not. So I cling to the pictures I took on that last trip. I'm standing on Hoover Dam here looking upstream, and you can see that big bathtub ring, we call it. So as the lake has dropped over the last 2 decades, it leaves behind a sort of sheen of white mineral deposits that really tellingly shows the story of shrinking Colorado River. Of course, being a university academic, I have graphs too, right? We've got to have our graphs. And this is the cumulative storage. That blue line is the cumulative storage totaled in Lake Powell and Lake Mead. The sort of pinky orange is Mead, the green is Powell. And you can see nearly full, 1999, 2000, nearly full, incredibly extreme drought conditions over especially the first 5 years of the 21st century. In the years since then, we've done an okay job of leveling out. I'm going to talk about some of the water use numbers. We've had a lot of ups and downs in the inflows. They actually haven't been scary bad in recent years up until this year. But all this space here is lost storage. All this space that you see, with the emptiness below the bathtub ring is lost storage because we have used that water, right? Some of it's evaporated. That's the price you pay for wet year, dry year storage options. And most of it we have sent on downstream to farmers and cities so that we can flush our toilets and grow the lettuce that we eat and the alfalfa that we use to make the burgers and pizza cheese that are part of our modern way of life. So we've been emptying out these reservoirs. Obviously, that can't continue, and we can't conjure new water. We're doing things like cloud seeding. We've given up on the idea of building large importation schemes from, the Missouri River, the Columbia, just vastly too expensive and infrastructure heavy relative to the amount of water you get. It's just hard to move these large volumes of water. So basically, this is the supply we have to work with. So what do we do? So how do we respond to the reality of mega drought, aridification, a sort of fundamental change in the available supply? remarkably, and I think this is counterintuitive to a lot of people who don't work closely with Colorado River Basin water use or municipal and agricultural water use in the United States in general. And so I'm going to spend some time on the numbers. Colorado River water use is actually declining, even at a time when population is growing, agricultural productivity is rising. We're being more and more efficient with the water we actually use. So I've got two lines here on this graph. This is water taken from the main stem of the Colorado River. So we're not talking about tributary use, coming down the rivers inside Arizona that they use within Arizona. This is from the main stem of the Colorado River. This is the water we take out to use. Peaked back in 2003. It has been declining. 2000, I think I haven't added the 2019 data yet. It actually declined a little more in 2019, and I'll show you some of that data as well. Water use is going down. We have, I haven't spent a lot of time on the administrative structure. We've kind of divided the Colorado River Basin up into an upper basin and a lower basin and kind of divided the water among them. The upper basin states are Wyoming and Colorado, New Mexico, Utah. Their use of Colorado River water kind of peaked in the late 80s. A lot of variability, interannual variability, but it's essentially been flat ever since. So we're seeing declining use in the lower basin, really flat water use for decades. And really importantly, this sort of gives lie to the myth that growing populations mean increasing demand for water. We're already seeing that that is empirically not the case in the Colorado River Basin. And if you look at most geographies in the United States, you see a similar sort of decoupling, peaking and declining, flattening, not for everywhere, but for most of the water use areas in the United States, you see this. So this is really important. I want to drill down into some of these numbers because they're fascinating to me. This is California. California is the largest user of Colorado River water, has the biggest entitlement. This is some very up-to-date numbers, and I have to especially thank the folks at the Bureau of Reclamation who do a great job of collecting this data, and then my friend Bill Hazenkamp and the folks at the Metropolitan Water District of Southern California dredged up some really interesting data sets that they've been sharing with me, looking at very, very old California water use. And this is actually amazing to me. It kind of blew me away when I started looking at these numbers last year as 2019 was ending. California's use of Colorado River water in 2019 was the lowest it has been since the 1950s. Now California uses other water, but in general, we're seeing Southern California's water use go down. And I just, shout out to Matt, the Met people have been Metropolitan Water District of Southern California. Half of those 40 million people are getting water from Metropolitan Water District of Southern California. Their use of Colorado River water last year was the lowest it had been since the 1950s. They're getting water from other places, so it's not that total water use in Southern California is that low, but you're seeing a real shift in Southern California away from the desire to import more water and toward sort of stabilizing the reliability of the supplies they have as we see aridification happening, mega droughts happening in Colorado River Basin and in Northern California, where a big part of their supply comes from as well. So you're seeing this this decline in water use. Like, this is a stunning success in terms of resource use by these major communities. And I'm singling out Southern California here just because I happen to have some cool data sets from that. But you see this trend throughout. Las Vegas water use has declined, Albuquerque's water use has declined, Phoenix. Even as population is going up, total water use is going down for almost every metropolitan water use area in the Colorado River Basin. So we're doing something right here. This is good. This is a success story. And yet, reservoir storage is still going down, right? See the bathtub ring. You can see that. You stand on, and whenever I have the chance, because I, former journalist, I'm interested in storytelling. I'm always trying to think, how can I see this and make it visible and understandable and tangible to the people I'm trying to communicate with. And so every time I have a chance, every time I get to Las Vegas, I always go out to Hoover Dam and look at that bathtub ring and take another picture. I have an amazing number of pictures of the bathtub ring, right? Because the reservoirs keep dropping. Done a better job, they're leveling out, they're stabilizing, but you know, the bathtub ring is real, and that's remains, you know, a serious challenge. So what do we do? What are the choices that we have? A couple of things. We're going to have to do more municipal water conservation. We have been extraordinarily successful in municipal areas. My hometown here of Albuquerque, our per capita water use today is half what it was 25 years ago, when we began a really aggressive water conservation effort. When you think about that, resource use in a rich world, you know, the way we consume resources in the rich world, a major resource cut in half per capita, and really not seeing a significant change in our lifestyle. This has not been a great sacrifice. When I moved into my house in the early 1990s, it had a lawn. Now it has no lawn. I have different kinds of plants in the garden, but I still got a great garden. People around me, there's a beautiful green park around the corner from my house. Few of my neighbors have lawns, not a lot of them. They're lovely. I don't begrudge them their lawns. We have been very successful in conserving water, and you see this across the arid West. Water use going down everywhere, even as population rises. So how much longer can that go on? Well, it's an interesting question. I don't think we know the answer, but to get a handle on this, for my previous book, Waters for Fighting Over, I spent a bunch of time looking at places around the world that had really come into water supply crisis, in places like Israel and coastal Australia, where we saw water conservation far in excess of what we're doing here in the southwestern United States. So I know, you know, if we need to, we can go farther than we already have. I'm not sure I know where the bottom is. It's a ways yet. We're not there yet. If you look at the performance of California municipalities in the drought of the early teens, a bunch of places that had been very successful at conserving water already did not see what we call demand hardening, where you've already done the conservation you can. They still were able to conserve a lot more. So we don't seem to have hit the point of demand hardening yet. We still seem to be seeing conservation heading in the right direction. That's good because we have more to go. But I think it's really important to not just look at our cities. Agriculture still uses the bulk of the water in the Colorado River Basin and throughout much of the arid West. You know, depending on where we're looking and how we're measuring, 60 to 80 to 90% of the water is in agriculture. And that's important for a couple of reasons. One, because it's food, and we all eat food. But secondly, and I think for me even more important, these are communities at the heart of this agriculture with their own ways of life and integrities that really need to be careful to think about how we respect them as we think about the future relationship of among our cities and our rural communities. And this is a point that, you know, Eric Kuhn and I, in our most recent book, really talk about, and as we think about the conclusions about where we head, is the idea of the importance of there being a need for a better urban-rural social contract. We're not going to have these big, rich cities just barge in with their wealth and political power and take water away from rural communities. You have to forge relationships that allow mutually respectful transactions to happen. And how we do those is super hard, but we have some interesting examples. And then we need better rules about how we share what remains as we continue to see these shrinking supplies. And this is one of the hardest problems right now, is we have a whole lot of people who look at the original legal structures around the allocation of the supplies of the river and they say, yeah, but we're entitled to all that water, and those other people need to give up water so I can still have mine. And so thinking about how we rewrite those rules in a way that we can share shrinking supplies. So I want to talk a little bit about the urban-rural social contract. This is from a research trip I took last summer down to the lower Colorado River deserts. It's a place called the Palo Verde Valley. Gorgeous farm country along the Colorado River on the California side of the Arizona-California border. You see a farmed field on the left, the green. You see a fallowed field on the right, and there's been a very successful program in Palo Verde, a collaborative relationship between urban Southern California and the farm district, the Palo Verde Irrigation District, where farmers are compensated for fallowing some portion of their land with the saved water used to firm up supplies in Southern California. Not so much to add to Southern California's supplies, but to make up when Southern California's supplies go short. Each of these arrangements is complicated. There are pluses and minuses to any way of doing this, but these are the kinds of models we need to think about, where we have collaborative, cooperative relationships between farm communities and cities that keep these farm communities alive. You know, the last thing we want is the old model, which we've seen in places that we call it buy and dry, where the rich city comes in, buys up all the land, dries it up, the farm community withers and dies, the people who sell tractors are out of luck, and the water goes to the city. And I think that's wrong, the wrong model. So there's sort of models out there for how we might cope with long-term megadrought, aridification, shrinking supplies. But there's also this final point, which is that as we allocated the water in the Colorado River and built all these dams and made all these plans across the 20th century, we had a very particular model of what we wanted to do, and it was development for the sake of farms and cities. And this was across the political spectrum. Everybody wanted to do this. It was what we did, it's what we planned for, and what we now realize in the 21st century is that there are communities that have been left out of that. And I especially think of the Native American communities, tribal communities. You know, I'm thinking about this a lot as I watch the coronavirus ravage the Navajo Nation, which has very little water, even though they have a large legal entitlement to water, because they were left out of the building of infrastructure to build economies and serve communities. So we have to think about who's left out. And then at the bottom of the system, and this is probably the most important challenge that we're facing right now, is the Salton Sea itself, which is a big inland body of water next to one of the largest farm districts, the Imperial Irrigation District, fed by runoff from the farm fields as we're more efficient in farming, which is good, right? We want to be more efficient in farming. We reduce the runoff, the Salton Sea is shrinking. This is, again, from the trip I took down there last summer. Newly exposed shoreline causing air pollution. Citation here from a new paper by a colleague and I, Benjamin Jones, economist here at the University of New Mexico, and colleague, looking at the impacts on human health, right? So we get all this toxic dust, a relatively poor community, again, left out. So we have to think about who's being left behind as we try to figure out how to build these new institutions and relationships around the process of using less water, and not leave, especially the less politically powerful communities, like the folks in the Imperial Valley suffering the air quality problems, or the tribal communities, the 29 tribes. You can't leave them behind. And then, and this is one of the things that kind of got me started on this path many years ago. This is a picture from 2014 of the now famous, but only happened once, pulse flow down the dry stretch of the Colorado River south of the US-Mexico border. We put some water in that dry stretch of river, and the communities around that once dry river saw water for the first time, and we saw some habitat, natural environment, emerge in ways that were modest but tantalizing in terms of the opportunities there. So at the same time as we're trying to figure out how to use less water, doing all the things we've been doing for years, farming in cities, we also need to be thinking about communities that have been left behind and didn't have water in the first place. And that's all super hard stuff. And partly I style myself an optimist because I think somebody has to model an optimistic path. I'm not confident we're going to be able to do all these things. I'm confident that they're possible if we stick on the paths that we're on and continue to build on the successes that we've had. So with that, I would like to thank a bunch of people, especially collaborators I've been working with lately, some really smart people that I've been working with and writing with, Eric Kuhn and Castle, Benjamin Jones, folks at the University of New Mexico, Bob Behrens, and my dean, Julie Coonrod, and then a whole bunch of people in that very long list of water managers around the West who've been working really hard on these problems and have been so kind and generous with their time and their insights as I try to think about how all this works. And of course, I'm bad marketing, but I have to try to remember you should buy my books, of course, and you should buy copies for Christmas for all your friends and spread the word as far as you can. That's how you can find me on Twitter, and I've got a blog at inkstain.net. And we'll got some time for a few questions, I would hope.
All right, thank you very much, John. Your presentation was super interesting, highlighting many of the drought challenges in the basin and some thoughts on what we need to do moving forward. We do have a couple questions here for you. Somebody asked you to speak a little bit more about why it's referred to as a sneaky drought. Specifically, this question says soil moisture mapping in November 2019 showed very dry soil in summer and fall, and experts, including Park Williams, use summer soil moisture as a proxy for modeling in the current mega drought. So since we know that soil moisture plays a significant role in eventual snow melt runoff that gets into rivers, should this be called a sneaky drought?
So a couple of things. You're absolutely correct. And the forecasters saw part of this coming. The general public did not, much less so. The general public pays attention to the snowpack and the ski areas. So the folks who were paying attention to the forecasts knew we were in for a drought, knew we were in for lower flows because of the soil moisture problem. The general public didn't, because they pay attention to, like, oh, what a great year at Breckenridge for skiing. It snuck up in that way. But then the way the bottom dropped out in, from the middle of April on, the curve dropped substantially from what the early forecasts had been, because it simply got dry. So it's the combination of those two things that make it seem sneaky.
Got it.
And yeah, it's just a clever slogan. We're as communicators, we're very much into clever slogans, and you can always find holes in them if you poke too hard.
Right. It's a useful way to frame it, though. And somebody asked if you could speak briefly about basin groundwater issues.
Yeah, groundwater has been less of a challenge in the Colorado River Basin than in many of the large water using areas in the West and Central United States for a couple of reasons. One, we do not have very many large agricultural areas like you would see in, for example, the Central Valley of California and the Ogallala, where we have just huge farming dependent on pumping up giant groundwater wells. Not a lot of that. There are exceptions to that, and you're seeing some really interesting problems in places like, the Wilcox, San Simon area of Arizona, where you're seeing expansion of large-scale net farming based on groundwater. The municipal areas that are dependent on groundwater across the Colorado River Basin have done better for a long time, and this is a sort of classic difference you see in groundwater use between municipal and and farm areas. Really famous stories. I talk about them in Waters for Fighting Over, early innovations in groundwater governance in Southern California. Really some of the great early models of successful groundwater governance happen in Southern California. It's not universal in Southern California, but pretty good. I mean, Albuquerque, my community used to be wholly dependent on groundwater. We've substantially reduced our reliance on groundwater such that our aquifer is now rising substantially. The groundwater underneath my house, there's a groundwater monitoring well 2 blocks from my house. It's like up 30 feet in the last 10 plus years. So we're seeing in these municipal areas that are dependent on groundwater much more success. The real problem areas are areas where you're seeing expansion of groundwater dependent agriculture away from places that are served by Colorado River water in the basin, and that's places like Wilcox in Arizona.
Okay, thanks. We have quite a few questions, unsurprisingly, about the drought contingency planning. Can you speak to where the upper basin states are at with the drought contingency planning, particularly with regard to demand management and possibly building a volume of water for Lake Powell to protect its operations?
The upper basin states, okay, so just some background for folks who aren't familiar with this. In the last few years, the Colorado River Basin states negotiated this giant complex web of interlocking agreements that we label the Drought Contingency Plan. I've always thought it was a terrible name because it's really an aridification. Climate change is reducing our river contingency plan, but that's not as good an acronym as DCP. In the lower basin, it included some rules that said when Lake Mead gets low, everybody takes less water. Relatively straightforward, not easy to implement, but in the upper basin, the challenges are more complex because we don't have single reservoirs that we're just taking water out of. So the upper basin agreed to study the possibility of establishing a program called demand management. And the idea is that you would somehow, and folks are still trying to figure out how to do this, compensate people to use water that they would otherwise use and somehow figure out how to stick it in a reservoir in Lake Powell or something as a kind of hedge against very bad years, series of very bad years. Right now, we're in the early stages of an implementation study to figure out what that would look like. And there's a bunch of questions. Who would pay for it? How much water do you need? Where would you put it? How do you ensure that if someone upstream is fallowing a field to get the water into the demand management pool, it doesn't just get grabbed by someone on the way downstream to the pool? There's a bunch of those issues. I think we're in very early stages of the development of those plans now. It's not clear that we're actually going to do it. Really, what we've committed to is to see what would be needed and how it might work. I think my colleague Ann Castle and I have argued that the risks are substantial enough that it is worth developing the tools in the hope that we may not need to use them. But it's still very much up in the air what that would look like and how we would do it and what kind of timescale it would happen on. Sorry to be vague, but it is vague right now.
Oh, it's a good, helpful answer. And also related to the drought contingency plan, there's a question on what can those in and outside of the Colorado River Basin learn from the process of developing the drought contingency plan, and where do you see drought contingency plans fitting in amongst the water management tools that we have?
So I think the most important thing about the drought contingency plan is sort of draws on, if I may engage in confirmation bias, a theme in some previous work of mine. My book Waters for Fighting Over argued that we are best served by the negotiation of collaborative agreements among partners and equals rather than the imposition of top-down solutions. And there's two reasons for this. One of them is we don't necessarily have the legal levers for implementing a top-down solution. It's not clear who has the power to enforce a solution, if we wanted to do something the way, for example, that they did things in Australia, where the federal government does have more powers in their federal system than ours. But second of all, it's better than the alternative, which is going to court and fighting it out, saying, you know, when there's shortage, I think the law favors my position, and that other state over there is the one that needs to suffer the losses. Because what folks in the Colorado River Basin have learned, especially through a really famous Supreme Court decision 50 years ago in Arizona versus California, is the courts make odd decisions. They are not as empowered with information as the sort of shared wisdom of the collaborative, and it's super hard to negotiate these deals. But we did it, right? And so that's important. Second important lesson goes back to my observation about the Salton Sea. We need to make sure we pull everyone into this. We need to make sure there's not people left out of the negotiation of these agreements. And in the case of the drought contingency plan, it was, I think, handled strangely in terms of the inclusion of the Imperial Irrigation District, which ended up being kind of left out of it for complicated reasons. But also the Native American community, the tribal communities, were really not given an appropriate seat at the table. And I think we need to fix that problem, and that's an important lesson to learn going forward into the next round of Colorado River Basin negotiations.
Okay, thanks. A few folks here are interested in hearing more about the urban-rural compact that you spoke about, and specifically about scale. City, district, like PVID, or are there other scales, and what can be done to promote this approach?
Yeah, so the knowledge base that we have is primarily at the very large scales. And so we've seen, for example, the agreement between the Palo Verde Irrigation District and the Metropolitan Water District of Southern California, a very large irrigation district, a very large municipal water agency, also agreement between the Imperial Irrigation District, an even larger water district, and the San Diego County Water Authority, and also between Imperial and Met. We've seen how these agreements can work at very, very large scales. One of the difficulties in thinking about, and I think this is one of the areas where demand management discussions in the upper Colorado River Basin are going to be critical, is thinking about how to do these at the smaller scales. You know, economists talk about transaction costs. This is just the friction of negotiating a deal. And you have transaction costs with a giant deal, and you have similarly large transaction costs when the deal gets tiny between a little irrigation district and a little municipal water agency. And so how we do those small district relationships, I think, is a challenge we haven't fully figured out how to sort out yet. But and so we've seen this, for example, in the pilot system drought conservation program, which was an effort sponsored by some of the big water utilities and the Bureau of Reclamation and others to try to figure out how to do these deals. Had a bunch of really neat ones that happened at very small scales, but the cost of implementation was super high per sort of unit of water. So I don't think we've solved this problem. But one of the really important lessons is that it's important for the people in all these places to get out to meet with one another. So you don't have folks in rural ag communities just kind of looking over their shoulder thinking they got a target on their back because they've got all the water and the rich cities are going to come after it. And, you know, I have a friend who's a water manager at a major municipal water agency who spends time hanging out with the farmers just to be sure they get to know each other, because when things get crazy, those relationships will help in figuring out how to do productive rather than conflictual deals. So hope that helps.
Okay, thank you. Another question here. It seems like lower basin demand decline started in 2003, which was forced by the onset of drought and has stayed low ever since. Why did the upper basin demand not decline similarly? And what potential strategies or policies can encourage conservation in the upper basin might be employed that are different than in the lower basin? We have about 5 minutes left.
Yeah, so I would try to reframe that question a little bit, because I think it's important to remember that the Colorado River Compact allocated the same amount of water to the upper and lower basin. So remember that graph, the upper Colorado River Basin is entitled to 7.5 million acre feet, only using 4 right now. So I think the discussion in the upper basin has to continue to be not about how to reduce, but how to not grow, because we're already using well under our entitlement. And the lower basin, I think, I'm got an upper basin perspective, right? I'm a New Mexican, an upper basin guy, but the lower basin's overusing. So I think the conversation needs to be about how to continue living within our means in the upper basin. And I think we've done that successfully. We're entitled to 7.5 million, we're using 4. We're kind of doing well. That said, when the hydrology gets worse, we use less in the upper basin just because we're at the headwaters. I have one of my acquaintances who's a farmer up on the Grand Mesa, who talks about how his runoff forecast is to look at the mountains off his front porch because he can see the water, and if there's no snow there, he's going to irrigate less. So we are already in the upper basin, I think, much more directly constrained by climate, and climate will enforce our use of less water as the climate gets drier. That's, I think, the reality. So I'm less worried about that. I'm more worried about the lower basin kind of getting lower yet, but again, that's an upper basin, lower perspective, and I have to try to remember water's not for fighting overs.
Right, thanks. I think, do you have time for one more quick question, John?
Oh, absolutely. I'm not going anywhere. There's a pandemic. I'm just sitting looking out on my back porch. All I have to do is weed and water this afternoon.
Okay, well, if folks want to stay with us for a couple more minutes, there are actually many questions, and I don't think we have time to address them all, but perhaps you could speak briefly to the structural deficiency in the lower Colorado River Basin. Specifically, this deficit is caused by allocating more water than annually available. Who is responsible to address this?
So the cause of this, Eric Kuhn and I, in our recently published book, Science Be Damned, went back and looked at the science surrounding this issue and concluded, I think, which runs counter to the traditional narrative, that in fact this happened because we ignored science even available as long ago as the 1920s that showed there was really less water in the river. So, blame to go around, a bunch of people who are dead, been dead for many decades. We're stuck with the situation we have now. The responsibility, again, falls to the collaborative nature of our governance structure. The folks down there running the system, folks at Southern Nevada Water Authority, the Metropolitan Water District and Imperial Irrigation District in Arizona and the state of California, they all understand that there's less water in the actual river than the compact provided. And so the responsibility for dealing with that is among that group of people who are working, have worked, and continue to work on negotiated agreements that reduce the amount of water use as Lake Mead declines. And I think that process, we've learned really well over the last couple of iterations of negotiations that we kind of know how to do that. We aren't all the way down the road yet. It's very difficult because lots of people think, well, we really need a lot of water, but part of what needs to happen too is this recognition that we actually have been so successful at using less water that we don't need to cling to the old paper fantasies of how much the compact actually promised us.
Thank you so much, John. Quite a few folks here have written in the question box how much they appreciate your presentation and your talk, how great it was. So thank you very much for sharing your expertise with us and for answering questions from folks. And everyone who joined us, thank you for joining us today. And we look forward to seeing you in future webinars.
Thanks much.
Thank you. Take care.